Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Paul Schoenfelder. He is the lead developer, well, at least one of the lead developers on Lumen. Why don't you go ahead and introduce yourself and tell us a little bit more about what is Lumen?
Sure. Thanks for having me. I am a software engineer. I have been for about 15, 16 years now. Got my start working in kind of like .NET, Java, enterprise kind of projects, blend of like product teams and consultancies. Around, I guess, 2011, 2012, I started working with Elixir, playing around with it, and then was able to kind of get a full-time job working with that. And that kind of kicked off my, I guess, career transition into working with Erlang projects and Elixir projects full-time. I can't remember what year it was. Maybe it was like 2017 or something. I, had been giving some talks at conferences, Elixir conferences, and met Brian and ended up applying and getting a job there. That was at the time I was working on deployment tools. Distillery and EXRM were kind of the things that I was spending the bulk of my time on. So I got hired to kind of work on those full time as part of my job at Dockyard. So about a year after that, Brian was looking at trying to bring Elixir to the browser. And I told him like, hey, I have this idea of how we can probably do that. And that was how Lumen got spawned. Basically the idea was we would try and implement a new compiler that would target WebAssembly, and allow us to bring the full semantics of the Beam VM to browsers. It just kind of went from there. The project has been ongoing since that time. I was working full time on it for about, I guess, 2 years. And then ended up leaving Dockyard just before the pandemic started. And now I'm working out, kind of in my spare time, but still trying to push that forward. We're pretty close to having, kind of a initial version of that people can use. It's really just issue of bandwidth and time, I think, that's held it up this long.
Yeah, I mean, it's pretty crazy. I remember looking at the demo before. It was like, how long did it take you guys to actually get to some type of state where you can demo like what you had?
Yeah, I think we spent that first. So the project idea kind of was discussed and started, I think, in November of, I'm going to say 2018. I might be wrong about this, but I'm going to say 2018. And by ElixirConf that fall, the next fall, which was, I think, September or something, very early September, like first week or something, we did our kind of on-stage, demonstration or proof of concept, I guess, of Lumen. So in that situation, we had our full runtime kind of built out, but the compiler part of it was still in progress. So what we did is we kind of had like a interpreter written in Rust that could consume sort of like the IR that the compiler was processing to actually run things in the browser. And then Imhoff, basically wrote Elixir programs in Rust that mimicked what they were actually going to do, using that IR. And that was how we did our like tech demo of it. So it was like 50% to 75% of the project was demonstrated at that point. The part that was still kind of completely undemonstrated was the compiler. And that's really where the rest of the focus has been since then.
So I know you guys are basically Elixir people, and Elixir is kind of built on top of Erlang, but it does have some more niceties to it. Like when I compile my Elixir applications, I always have an Elixir app that has some extra stuff in it. But I believe Lumen's at a spot where you guys can only compile Erlang. That's what I last remember. Is that still true? Or
yeah, so right now Lumen targets Erlang, so it is a full Erlang front end. It does everything from reading in the source to parsing it and transforming it. The idea there was that with an Erlang compiler, we could then support any Beam language, as long as they could output either Erlang abstract format or Erlang core format. And, for example, Elixir internally basically compiles down to Erlang abstract format. It doesn't target core, but languages like Gleam, for example, do target core. LFE, a few of those are all focused on targeting core. So our compiler, we wanted to support either one of those and ultimately be able to act as like a foundation for the community, just like the Beam does. And Elixir, was kind of the thing that we cared the most about was really Elixir, but Erlang was the means to get there.
So wait, when you're talking about core, right? Because this is a Rustacean Station podcast, we probably don't really know what you're talking about when you're talking about
sure,
core. Yeah, so maybe we can back it up a little bit, right? And also, like, we did have the guy, I forgot to say Louis, forgot his last name now. It's still a little bit early for me.
Pilfold.
Yeah, Pilfold. Yeah, he came on the show to talk about what he does. And so I believe his compiler will actually take his Gleam and compile it to Erlang code, and then you just compile that one. So it's like a double compile going on. But you're saying that you guys are going straight from Erlang code straight to WebAssembly, right? There's no intermediate step over here.
Right. Well, I mean, we have our internal intermediate format that we use inside the compiler, but that's not exposed in a real way. The way that the Erlang compiler internally works is you read in kind of that high level Erlang source code, and then that gets converted to essentially like a syntax tree. That syntax tree gets transformed into a format called core, which is, been simplified and reduced, transformed to be kind of like the fewer high level sugary syntax constructs and things like that. This is like post semantic analysis and things like that would normally happen in the front end of a compiler. That core then is where a lot of the optimizations take place, high level optimizations, like pattern match, compilation, things of that nature. And then that gets converted to kind of like it's called kernel inside Erlang, but it's like a lower level format that's just more of like a traditional SSA representation. So in Rust, for example, you kind of go through mir, and then that gets lowered to LLVM IR, which is an SSA representation. And that is kind of equivalent to what kernel is in the Beam. Kernel then gets compiled to essentially like Beam assembly. That's ultimately what ends up in the .beam files that end up on disk. It's just the bytecode. There's some magic that happens when those Beam files get read off disk into memory and then start executing. They kind of get expanded into more of optimum format for whatever the native machine architecture is. But, a lot of optimization happens up front. So in our compiler, we're not targeting a virtual machine. We're a ahead of time compiler. So we are targeting LLVM IR. But we have our own intermediate representation that we compile, Erlang source code to. So when I say that we wanted to support either Erlang abstract format, which is like the very high level, the thing that Erlang source code gets parsed into, or core format, we're saying like either that high level like syntax representation or that first level of simplification and transformation. Either one of those stages we have a parser for. So we can take those in as input formats and then translate those into our intermediate representation that gets lowered to LLVM IR and then compiled into a binary.
So there's so many things that's still new to me, but I followed most of it. The only thing I didn't quite understand was what is the SSA. I had to look it up in the background because I don't think everybody using Rust is
static single assignment.
Yeah.
Yeah, that's true. I always lose track of like how much terminology is like commonly known or not. SSA stands for static single assignment, and what that basically means is that every expression has a single value that it gets assigned to. And so you never mutate a value that has been defined. Like, so you'll have, var1 that has some initial definition. And then let's say you want to add one to that value. You'd have var2 equals var1 plus 1, and every mutation of a value has a new name to it, I guess. This form is very easy to transform into more optimal format. There's various things you can do on it, like dead code elimination. You can reason better about data flow. And yeah, that format is more akin to how the machine is dealing with things than it is how you work with it at a high level. Some languages are more, I guess, closer to that. Like, for example, Erlang has no notion of mutability. You define a variable, you can't like rebind it or, mutate that value. You have to define a new binding for it. That's actually quite similar to how SSA works in practice. But that's like a really high level explanation of it. It's definitely leaving out a lot of context and sort of information about what SSA really is used for. But I think that probably is the easiest way to reason about it. Hopefully that answered the question.
Yeah, I got most of it, but it'll take some time for it to start to sink in. Sadly, my computer science program never covered compilers, but I think a lot of people have that in their CS program. What about, because we were kind of discussing some other similar projects, right? You got Lumen, but I mean similar, I mean like writing another compiler for Beam-based languages. When I say Beam-based languages, that's all of the stuff that runs on the Beam. Beam is like the JVM for like Erlang, Elixir, Gleam, these types of languages. Just want to kind of reiterate for people in the audience. Now, like writing all this stuff from scratch is really a hassle. I think I heard when you were describing the story, like from idea to first demo was like around a year nearly, if I listened correctly. Then
it was about 9 months.
Yeah, but nearly a year, right? I think you said November till the following September, which is quite some time. Mm-hmm. So like with projects like Gleam, and then I did some looking in the background. I think there's Erlang RT, and then there's Enigma. Like, is there any reason why you guys cannot work together on something to kind of make this process easier?
So we've talked with the leads on some of those projects. I think all of them, maybe one of those we might not have talked with. I think there were a couple things. One is that not all of those projects were necessarily interested in WebAssembly as a target. They were more interested, and there was a couple different angles people had. One was personal project, just interested in kind of like learning more about how the Beam was implemented, and learning Rust. It was a way to kind of like implement something that they were interested in to learn it, and also learn more about using Rust. Another one was about basically re-implementing the Beam as an educational tool for others to make it easier for them to learn how the Beam works so that they could contribute to the Beam. And almost in all these cases, they were implementing a virtual machine. So they're essentially re-implementing the Beam, kind of, from C to Rust in some different, they took different angles to it, but ultimately that was kind of the end result that they were going for, is to re-implement it one for one. There were a couple reasons why we didn't think that was the right approach for targeting the browser. And I think this is debatable, right? Like, I don't necessarily think that our idea is the one true way, but there are a couple of problems that I found with trying to, like, for example, the very first thing I evaluated is whether or not I could take the Beam as it is today and make it target WebAssembly as is. Modify the Beam in whatever way necessary to allow compiling the Beam itself for running in browsers. That turned out to be a pretty monumental task. I'm not even sure if that's ever going to happen. I think it's possible, but it would take an enormous amount of time, like longer than Lumen would take to build. And one of the big issues that I found with it is that, you have this notion of compiling a program down into Beam bytecode. So you have potentially thousands of these bytecode files that you have to then ship to the browser in some way. It is because of how the Beam works. It doesn't do any form of like dead code elimination or anything like that, because at any point you can change the definition of a module at runtime. That's kind of the hot code loading aspect of the Beam. And because you can call any function just by basically building up a symbol and using like the apply function, for example, passing in a module function and a list of arguments, you can never really reason about whether or not a function is ever going to be called. So what you end up with is shipping a huge binary to the browser for any given application. Like the smallest application, or not the smallest, but for example, I took one of my libraries. It was a little bit bigger than some of the ones I had written, called Timex. It's just a datetime library that has a bunch of different types of functionality. And just compiling that and adding it together with the Beam itself, I think was something like 25 megabytes or something like that. It's been a while, so I don't remember the exact number, but it was in that ballpark. And that's just way, way, way too big. Like that's absurdly huge for the browser. Even if you tried to compress that data, and I'm not convinced that you could get very good compression out of that, you're not going to reduce it by enough to make that competitive with any of the popular front-end languages today. So you need to be able to do a couple things. One, you have to be able to reason about what's actually going to be used at runtime and be able to strip out anything that's not. For example, like one of the things you have to do if you're going to ship, Beam to the browser is you have to ship the entire Erlang standard library with it, which is huge just on its own. But if we compile ahead of time and say that, like, for example, we're going to forbid hot code loading, then that allows us to do whole program analysis and actually strip out the parts of the program that are never going to be called. The binary itself at link time can be optimized to strip out parts of the standard library that are never going to be used, things like that. And so the result is you end up with a very small final binary. One of the other aspects of this that I was particularly interested in was making FFI a little bit easier to accomplish. The Erl-NIF interface, that's kind of Erlang's way of exposing C FFI to Erlang programs, is extremely awkward, I found. And I wanted a way to make that easier to write native plugins for Erlang programs, and I mean Beam languages in general, but also make calling native functions a lot easier. And so by writing an ahead of time compiler and having the calling convention of Erlang programs match like the C ABI as much as possible, there's some translation needed if you want to, like, in a C plugin, manipulate Erlang terms. Like there's some things that you'd have to do there. But we are able to make that much, much easier and more pleasant to work with. And that's going to be necessary if you want, like, to call from Erlang into JavaScript and vice versa, or, across WebAssembly module boundaries, to things that are written in other languages, not just C or JavaScript or something. So that was one of the other pieces, I guess, was that we wanted to make it play nice with, kind of what was going to be more likely in the front end world, which is cross-language compatibility. I think those are kind of the major aspects of it. The rest of it I don't think is so important. I think from a performance perspective, we might be able to do better in some cases, but in others we might not do as well as the Beam, just because you can do a little bit more at runtime in a virtual machine in terms of optimization that you necessarily can with an ahead of time compiler, unless you're explicitly introducing a JIT into the equation in some way, which is something, the Beam recently added, actually.
So if I understand correctly, right, we won't have this ability to do hot code upgrades, which I think makes some sense, because how are you going to do that if somebody's like running your app like on their browser, you have to ship it over a WebSocket or something, which could be difficult if they have like a spotty connection or something.
Well, WebAssembly itself is...
but still would be kind of interesting.
Yeah, I mean, it would be interesting to be able to do that. And I think it would be a nice feature to have. WebAssembly as it exists today, though, doesn't really play nice with that sort of thing, at least as it is today. And I mean, in general, WebAssembly as an architecture, as a target, is trickier than pretty much every other target, because of the fact that it tries to protect the system before it tries to give you things that you can use, right? So it doesn't care about giving you power as a compiler writer. It cares about protecting the host machine from, unsafe kinds of situations. So loading code from arbitrary places in memory and executing it is not something that it likes. It separates the memory region in which the code lives from where the data lives, which is unlike most other architectures where you can, allocate some memory, compile some code in there, mark it read-only and executable, and then start executing code in there. WebAssembly doesn't give you that kind of capability. There might be some hacks that you can do by calling out to the host, having the host like load a module dynamically and then link the two modules together. I haven't explored that because, it's basically a use case I don't think is probably important. In the vast majority of cases, people are going to write an application, ship it to the browser. It's going to run. And if you need to load a new version of something, you're going to refresh the page. It's like loading code dynamically is probably not something that's going to be a use case that's very important. That's not to say that there might not be some use cases for it, just that we thought it was a worthwhile trade-off to make, I guess.
Yeah, that makes sense. Okay, so similar to Gleam in the fact that you guys are not shipping some special virtual machine, you're just going to be compiling the AOT directly to WebAssembly. So it does differ from the original Erlang implementation where you actually have bytecode, which will be run on a virtual machine.
Right.
And that's mostly because it's going to be very heavy, right? And you can't do kind of optimizations to strip out things that you may or may not need.
Yeah, exactly. That was kind of the primary concern there. I think if we didn't have that constraint, then the virtual machine approach probably would have been faster. Primarily because right now one of the limitations we have with targeting WebAssembly is that implementing things like stackable coroutines or continuations or stack switching is just not, like, there aren't utilities to implement that. There is one kind of hacky approach that kind of works, but it's so inefficient that it's basically impractical, and that's a transformation called Asyncify. The approach I've taken in Lumen's compiler currently, just to get something that kind of goes through the whole process of our compiler and can run in the browser today, is using a transformation like that. But long term, I don't think that's actually viable as something that's like production ready. And so I'm participating in a WebAssembly subgroup called the Stack subgroup that is exploring different solutions and implementations of things like stackable coroutines, continuations, stack switching primitives, things like that. So as an example, like on x86-64, you might implement stack switching by allocating multiple stacks and switching between them using like persisting all the call save registers in the heap somewhere in like a structure, and then switching between instances of those structures by popping values off those registers into that structure and then popping them back out of that structure into the registers. That's things like the stack pointer, the frame pointer, all those registers that are caller saved, sorry. And another approach to doing things like continuation is using things like set jump and long jump. That's not available to us on WebAssembly. I think that's kind of the major obstacle there. And a virtual machine just doesn't have that problem because it's processing a stream of instructions and they can mean whatever you want them to mean, instead of trying to use the WebAssembly like assembly to actually execute those things. if that makes sense. That was very poorly explained. I'm not sure that actually makes sense, but hopefully you get the gist of what I'm referring to there.
Yeah, my mind's still kind of, for one, it's waking up. For two, it's
very low
it's still
level
trying
details.
to understand all the stuff. Yeah, exactly. I feel like my CS program never went detailed enough, but it's fine. I can take some time to dig into it. I think that's like kind of the power of Rust is like it makes low level kind of stuff like this easier to implement. And then once you have the understanding, then it should be easier to actually do. That's just my feeling so far with what I've been playing around with Rust.
I mean, a lot of things around this were things that I learned along the way. Like I've been interested in compilers for a long time, but in the process of trying to figure out how to translate something that works well on most other architectures like x86-64 or AArch64, like trying to figure out how to translate how you would compile something. Like as a simple example, scheme is a list, type of list, I guess is a better way of referring to it, that has a notion of continuations. So a continuation is essentially a way to capture the execution of the program that follows the current program counter, right? So you can say like capture the current continuation and then switch to doing something else and pass that continuation handle, I guess, along with the execution of the program. At some later point, you might then want to jump back to where you captured that continuation, and the continuation lets you call it like a function. So you can essentially switch between threads of execution by passing that continuation around or capturing continuations and calling them later. A very common way of representing multiple threads of execution in compilers is some form of continuation. You can basically every form of control flow that you can think of could be represented using continuations. So it's a very efficient way of representing very novel concepts like effect handlers, coroutines. I guess the notion of stackful coroutine is really just another way of referring to a continuation. So it gets kind of an impractical or redundant thing to call it. But in Erlang in particular, you have this idea of processes, right? Independent threads of execution. You can have millions of them running at the same time. And the scheduler, which is, running in C, you have like one scheduler per CPU thread, is basically queuing these processes up, these threads of execution up, popping them off, letting them run for a little while, and then switching back to the scheduler to queue those back up and dequeue another one. All of that can be implemented using continuations, where, when you switch to process that's going to run for a little while, when it decides to switch back to the scheduler, that's just calling a continuation that was captured in the scheduler. And that was the representation that I basically chose in our compiler in order to represent this stuff in Rust. There are a bunch of low-level details around how I represent continuations, how they get captured, but that was the goal, is that they can be used to represent all sorts of different types of control flow, including things like exceptions, which in Erlang are extremely efficient, much more efficient than like panics in Rust or C++ exceptions, which are zero cost if you don't throw them, but they are expensive when you do, because they have to unwind the stack and perform cleanup and all that stuff. In Erlang, they're extremely efficient because none of that is true. It just essentially is like a jump. And so by using continuations, I could represent Erlang exceptions very efficiently as well. Unfortunately, as I mentioned, because WebAssembly doesn't provide you any primitives to implement continuations efficiently, that approach doesn't really work. Like there is no good way to do that. Instead, I don't really want to get into the details of how like the asyncopy transformation works, because it's fairly like technical and detailed, but needless to say, it works, but it's very slow. Because you're having to preserve a lot of intermediate state of the stack when you're executing and when you're unwinding it. And that's so that you can essentially replay where you were on the stack when you suspended execution. So that's where I kind of find myself with Lumen and WebAssembly at the moment, is trying to find a way to get something that works efficiently, therefore making it worth using Erlang or Elixir on the front end in the browser. The subgroup has made some progress on this, and there's some interesting proposals. I'm working with some people on starting to try and get an implementation of that stuff tested, so kind of a proof of concept for WebAssembly using the WebAssembly interpreter, as well as an implementation that runs on one of the WebAssembly runtimes, WASM time. With that proof of concept, then we can try and push that proposal forward and actually get something, merged into the spec itself, and therefore get merged into the implementation of the browser engines. But that's probably a year away, optimistically. I would guess that it's probably more like 2 before that's actually something that, is available in all the implementations and isn't like hidden behind a flag or something. But yeah, I mean, in the meantime, we do have kind of that, hacky approach that I mentioned, and that allows us at least to do some interesting demos in the browser, as well as continue to develop some of the other aspects of this, like fleshing out the runtime library, starting to build some tooling for the browser for Elixir applications. But that's all work that I think, we're going to depend on the community to some degree to support. We want to be able to get the compiler done and have that be kind of what I'm focusing on. But I think a lot of the extra tooling and libraries and things like that for building UI applications in the browser, that's going to be stuff that we really rely on the community to develop and provide. Assuming people are interested in it, that's, I think at the end of the day, we've heard a lot of positive things from people. The community is interested in this as a project. They want to see it come to fruition, but will it take off? Will it be something that people really kind of rally around and turn into something interesting? I don't know the answer to that. I like to believe that, they will, but it remains to be seen.
I think for me, I tend to stay away from these kind of projects, and that's because they're very fragile because, nobody's bought on. It's kind of like if you don't have the supply, then I don't really want to have the demand from it. I don't really demand to use it. And the same, if from the other side, like your guys' side, nobody's really using it, then why are we continuing to work on this thing?
Yeah, it's a tough place.
That's another thing. So, because I recently looked at Elixir script because we have this episode coming up. So Elixir script, I think, is definitely different. So where it's not targeting WebAssembly, it's like it's transpiling, I think, Elixir to JavaScript.
Syntax.
And I know you guys,
basically.
Yeah, and I think you guys talked to him, Brian Joes, or I forgot his name, something like that, Brian something. But didn't work out for whatever reason. You guys working together on something, but I looked at his project and it hasn't been touched in a few years. So that's why I'm like, well, I'm happy I didn't go to that because I may be in some troubles if I need to update something recently.
Yeah, and I mean, I think there's 2 things. We were working with Brian, or I guess, we wanted Brian to participate in Lumen, and I think he was interested. There just wasn't a whole lot that he could take action on, with the project being where it is. But it's something I think that he was interested in, helping move forward. And a lot of what we were interested in was his perspective on how to actually build kind of the browser side of that, right? What kind of frameworks would we build on top of that? What are the APIs going to look like? Things of that nature. But Elixir script as a project, I think, is very interesting just from can you transform Elixir into something that can execute as JavaScript code in the browser, but it loses all of the interesting semantics of Elixir, or really the Beam, I guess. The notion of multiple processes, supervisor hierarchies, kind of all the tenets of what makes Erlang and Elixir what they are lost because what you're really doing is a surface level transformation from one syntax to another, but you've lost kind of the fault isolation and recovery, the concurrency tooling, all that stuff.
Yeah, actually, there's so many questions I have. I'm curious about what kind of things can you bring to the browser and what can you not? one of the coolest things and best things to have about Elixir and Erlang, it's been talked about so much, is like the telemetry options, like especially with the observer. We can connect to a running instance to see what's going on. I'm guessing that wouldn't be possible to have any kind of thing like that.
Well, one interesting thing is there's two approaches that we explored on that. And obviously, like, this is more design. We haven't implemented this, but we're pretty sure one of these two approaches would work. One is to allow connecting observer over like WebRTC, to, running instance in the browser. This would be more for like local development, right? I guess I'm not sure it's really viable for like remote development of a production system, but, it is feasible to connect. Like, we'd have to implement support for this observer, of course, but being able to connect using the distribution protocol over WebRTC would be interesting. The other approach would be to develop, browser, like a plugin for like the developer tools that is able to interact with and understand kind of like the Erlang aspect of it, right? Again, we could probably use the distribution protocol for that, even though they're running, essentially in the same process. We could treat them as like two separate nodes. That would be one interesting approach. And that was also kind of the approach I was thinking that could make sense for like a runtime shell. If you want to interact with the program, and actually type in some commands and things like that, you would in a typical Erlang shell. The downside to that is that if you wanted that capability, you'd also have to ship, the compiler with it, which would bloat the size of the application a little bit. But that could make sense for like development, right? If you want to be able to have some extra capabilities, then it's not a big deal to have like a dev build where you include some of those extra components. But those are kind of the two angles that we explored. I think either one of those would probably work as an option.
Yeah, but I think it's also going to be kind of go over like what is the observer, because I think most of our audience is not Erlang developers.
I mean, it's hard to even like understand, honestly, if you haven't used it before because of how unique it is. I think it's honestly one of the biggest powers that Erlang or the Beam VM has in general are its operational tools, things like the runtime shell and observer. But for those who haven't used them before, observer essentially is it's a GUI application that lets you connect to the running application and see things like CPU usage, scheduler usage, allocator usage. There's a notion of kind of like an internal database and memory database called ETS, or Erlang Term Storage. You can see all the tables that have been defined in that, as well as all the values that are in there, how many values they are, how much space those tables are taking up. You can see all the Erlang processes, essentially threads that are running, what the names of those are, where they are in their execution. Like, you can capture a stack trace. There's, for each one of those threads of execution, there's something called a process dictionary. It's essentially like a local, like thread local storage, basically. It's mutable. You can poke and prod at that. You can kill processes, like interact with them. If there's something that's like causing problems, you can go in there and you can basically kill it just like you would in a, task manager on your local desktop or something. It's very powerful. It provides a boatload of information about the running program. And you can have it attached to, a live system. It's exceedingly useful. Erlang systems itself have a built-in shell that, is, you interact with it using Erlang syntax or Elixir syntax in the case of Elixir programs, and gives you the ability to define things at runtime, interact with modules that were defined at compile time, call functions, trace execution. There's all kinds of capabilities that are hard to get into if you've never used the language before, but both of those facilities are things that I think are very unique to the Beam as a platform. I think maybe Java has a few facilities that come close. I think you can attach to the Java virtual machine to get some telemetry from it, but it's definitely limited, I think, in comparison to what you can get via Observer. And there's, as far as I'm aware, there's no other language that provides that kind of runtime shell that lets you interact with the program the way that the Beam does. And maybe the closest one would be
Let's say what else is really cool too is they have a built-in distribution.
Mm-hmm.
And with the observer, if you have these nodes hooked up to each other, so each running process of the beam, when they connect to another beam, they're called nodes. And I think if you connect to one node, one running process, then you can connect to the other ones who it's also connected to, if I remember correctly.
Yep.
Which is even more powerful, right? So if you have a farm of 100 instances of your application and they're all talking to each other, you just connect to one of them, then you can visit any of the nodes that you want to visit, no matter which one it is, which is really crazy.
Yeah, it's awesome. There are some downsides to having that like mesh network basically that gets formed by how distribution protocol works, but it's also exceedingly useful when you want to connect to a cluster and then poke around at each one of those nodes to get more information. These days with if you're running on a Kubernetes cluster and you're gathering a bunch of metrics and pulling all that into like Grafana dashboards and things like that, maybe it's not as important to have something like Observer. But there are still times where it's valuable, I think. And it's really hard to understate just how much information it provides you just out of the box without you having to configure anything, do anything. It's just ready to go.
I think I want to kind of roll over to WebAssembly. So we actually had a guest last episode that we recorded, not out yet, is a guy who's one of the maintainers of YEW. I'm guessing you probably looked at that one because that's definitely targeting WebAssembly.
That strikes me as familiar.
Yeah. YEW.rs is their website. And so the only thing is he's kind of a newer developer in terms of like his understanding of what WebAssembly is. And obviously, I'm pretty sure since you're on the working group, you have some idea at least what is WebAssembly. Mm-hmm. So I kind of wanted to talk more about like, what is WebAssembly? Why should I care about it? Should I even take a look at it? If I'm a seasoned Rust developer, should I actually try to play with it? What do you think?
I mean,
so maybe you can start with any of those. I think the most part is let's define WebAssembly because we didn't actually talk about that.
Yeah, let's start there for sure. I mean, WebAssembly, like the way I think about WebAssembly anyways, I know it's very easy because web is in the name to think of it as like a browser only thing or a JavaScript only thing. And I don't think that's accurate. WebAssembly has really grown beyond its initial roots, which I think, if I remember my history of it correctly, evolved really out of ASM.js, which is a way to kind of optimize JavaScript programs that were doing more compute-bound kinds of problems. WebAssembly has turned into essentially its own architecture. So you could think of it in the same way that you think about different types of targets that you would compile for. Like if I'm going to compile for x86 systems or ARM64 systems, WebAssembly is just another one of those. That's why Rust itself has I think there's two target triples, one for WASI and one for non-WASI. But it's WASM 32, unknown is kind of the default target triple for WebAssembly. And it has all the kind of like instructions that you'd expect in a typical instruction set. By default, it doesn't really give you a whole lot of like host functionality. It's essentially just an empty system. You can't call. There's no like libc or anything. It's defined by the host. So in browsers, that the browser environment provides you things that you'd expect to find in a browser, but there are also WASM runtimes that live outside of the browser. They're completely separate from it. Cloudflare workers, for example, I think is one approach. I'm trying to remember. Fastly also has their own kind of edge compute solution. Both of those are implemented on top of a WASM runtime that provides more, I guess, what I'd consider like POSIX-y or Unix-y host functionality. Reading and writing files, talking across the network, things like that. And so from my perspective, and I mean, there's even solutions, I think, that run WASM things on the blockchain via like the Ethereum VM. That's well outside the scope of things I've really looked into. So I don't really think I'm qualified to speak too much about how it's used in that space. But in most of the problem space I'm thinking about is it can be used for executing arbitrary programs in a safe manner, like essentially sandboxed by default. And it's up to the host to define what kinds of external functionality they want to provide to those programs. So instead of having to worry about how am I going to lock down this program to do something that is executing some untrusted code, by default, you don't have to worry about that at all. The program can't do anything unsafe unless you give it the tools to do unsafe things. I think that's a paradigm shift in how we think about programs.
Can we back up a second?
Yeah.
When you say you mean you as in you, the user, or you as in you, the developer who's developing WASM? I just want to make that clear.
Yeah. So I think, as a person that is providing a service like Cloudflare workers, for example, the programs that are executing on those workers are effectively untrusted. Your customers are writing code that then gets executed on those workers, and you don't really have any control over what that is. That's really where WebAssembly has, I think, been a boon for them, is that they don't have to worry about that. Instead, they can tightly control what types of things those programs can do in terms of interacting with the outside world. And that makes it much easier to kind of sandbox and control those things and ensure that they're, not kind of breaking the rules, so to speak. As a person that is writing programs, it means that, as a user of something like Cloudflare workers, it means that you can use whatever language you want to write programs as long as they can target WebAssembly, compile to WebAssembly. And if they can, then it's really just a matter of ensuring that, the ecosystem for that language understands, whatever functionality Cloudflare workers provides, for example. And that's where specifications like WASI, which builds on top of what WebAssembly provides, is WebAssembly System Interface, I think is kind of what that stands for. And that's providing more kind of the POSIX-y things I was talking about, like reading and writing files and so on. Things that you'd have a syscall for in like libc or in the kernel, are things that WASI intends to provide. And WASI is intended to be kind of like a cross-platform, cross-runtime, consistent interface for those things. So instead of having to have your language of choice know the differences between Cloudflare and Fastly and Chrome and Firefox and every single different WebAssembly implementation out there, it can focus on supporting WASI. And then whether or not the actual target that you're deploying the WASI program to supports some particular feature, it's just going to fail to load if you try and use something that hasn't been supported on that host. But that means that things are a lot more portable, and in general, I think makes it less important that a provider support your favorite language, and instead it puts the power and control of a compiler or language author to be able to target WebAssembly and then enable you to use that language anywhere where WebAssembly is supported. And WebAssembly can be embedded in programs, so it could be used for like embedding a scripting engine and a video game, or really any program for that matter. It can be used to embed scripting engines and platforms where, like, for example, IoT, where you're streaming sensor data and things like that to some sort of central platform, and they want to provide you the ability to like write programs that operate on that stream of data. Well, if they do so with WebAssembly, they can allow you to use, again, whatever language you want to interact with that data and support it without them having to provide you some ad hoc language, that has different API than you're used to, doesn't have all the tools that you're comfortable with, that kind of thing.
I want to stop for a second, right? So this is the question that came up in my mind. Like, I'm aware that you can, like, there's like cross-site where you can run some type of WASI. I guess it must be WASI compatible WebAssembly. But I'm thinking about like you, right? So specifically with you can interact with the DOM. Mm-hmm. And of course, with WebAssembly, you can of course interact with the DOM too. But now, how does that play with if I write some code that interacts with the DOM, but I try to run this code on some type of WASI compatible thing? How is it going to handle this? Or is it just like, if you're going to write to the DOM, you can only write strings, and then with a string, you can write a div tag? Like, is this kind of how it works? Or You don't quite know about this part.
With WASI, like the DOM stuff isn't part of that at all. But my understanding of how they've defined the WASI stuff is that if you try and load a WebAssembly module that uses features that are not enabled or supported on that particular runtime, it will fail with an error of like, use of unsupported feature or whatever. You could also, my understanding is they also support conditional loading of certain functions. So let's say like one optional feature that was not in the WebAssembly MVP, but is now, made its way upstream. There's implementations in some of the browsers, which is SIMD support. So kind of like low level vector operators or instructions. If you have a version of a function that is SIMD support and version that's like kind of the unoptimized non-SIMD supporting version, you can define a WebAssembly module in such a way that if SIMD support is available, it will use that version of the function. Otherwise, it will use the unoptimized version. I don't know.
It's kind of like the CFG where you can say, if this is on Mac OS, use this function.
Yeah.
If it's on web, use this one.
Exactly. Okay. That kind of thing. And so I think that's how they've approached doing that. I gotta be honest, it's been a while since I looked at where that sits, but I'm pretty sure that was kind of the approach that they figured was going to make the most sense. But my understanding is if you don't have that conditional kind of thing available where you're saying like this WebAssembly module requires this feature, then the module will fail to load and it'll say like this use of this feature is not supported or something like that. It's going to depend on how the runtime in particular surfaces that to use an end user. But basically it's all or nothing in that situation. I think when it comes to manipulating the DOM though, that's where things get like there is no spec for that. So the way that works today is that you expose functions to the WebAssembly module that can be called from WebAssembly that are implemented in JavaScript. And that JavaScript code is what actually does kind of the DOM manipulation. So, for example, when you compile Rust to WebAssembly that's going to run our browser today, like via WASM pack, the WASM bindgen stuff creates a set of bindings that provide implementations of certain things in JavaScript that are then exposed via APIs that you call in Rust, right? So that's how you get access to things like JavaScript values and so on, and are able to write functions that kind of pass values across the boundary either way. A lot of that support functionality is implemented in JavaScript and gets bundled into the program that you ship to the browser. So what you'll get when you compile a Rust program to WebAssembly for a browser via WASM pack is you'll get the WASM blob, but you also get a JavaScript file. And both of those things are required to ship that thing and actually use it in practice in the browser. I don't know if I haven't heard of any efforts to provide like native WebAssembly functions that do DOM manipulation, but I think it's a logical evolution of where this stuff goes over time, right? Like we're still, relatively speaking, early days of all this stuff. There's a lot of movement in various directions in the WebAssembly working group on different initiatives to make certain things easier to write. For example, there are proposals on kind of like a form of garbage collected references that would allow for safe passing of JavaScript values into WebAssembly. So that means that instead of having to kind of mimic that via some form of handle, you could directly pass DOM handles into a WebAssembly program and they can be tracked in WebAssembly. One of the concerns with JavaScript is that, they need to not lose track of garbage collected items that need to live on the heap, the JavaScript heap, by passing them into a WebAssembly program. They have to maintain kind of like the notion that this thing is still alive. And so support for that needs to be something that is introduced into WebAssembly proper. I think that's almost, I don't know if that's made it all the way into kind of like the final form of the spec. I think pretty sure it's a stage 4 proposal at this point. But But anyways, I'm kind of getting off the beaten path here. The point is that, it's a living spec. There's a lot of things being added to it, a lot of very useful things being added to it, including the stuff that we're working on in the Stack subgroup. So I think that where we'll end up one day is that kind of JavaScript as the first class citizen of the browser will be less true. And it'll be WebAssembly first, with JavaScript being kind of like the built-in first class language that, runs on top of WebAssembly. That's my hope anyways. I would prefer for us to move away from a world where like JavaScript has kind of preferential treatment in the browser. It effectively does because, it is the language of the web at this point. But my hope is that WebAssembly becomes that first class citizen, and JavaScript is just yet another language that runs on WebAssembly.
Yeah, that would make more sense. Makes things a little bit easier, because now the argument is, why should I learn another language where I can use JavaScript on both the front end and back end?
Right. And I mean, that's a very true argument. I think it's definitely something that's less compelling on the back end. But in terms of the front end, I definitely agree with the sentiment that, it gets the job done. There's a lot of supporting tooling out there for it. Why fight it, I guess. But from my perspective, we have to move this stuff forward in some way. And the way we do that is by implementing first class support for, running other languages on the front end. People want to be able to use the language they use on the back end on the front end. They have to use JavaScript on the front end because that is lingua franca of the web. But that's just the state of things as they are today. That's not necessarily because people want to use JavaScript on the front end. Of course, there are many people that do. I'm not saying that that's something people want to get away from, but there's certainly a large number of people that would prefer to use Rust on the front end, or use a dynamic language on the front end like Ruby or Python or Elixir or whatever. And I think we want to move to a world where that is an option, right? Unfortunately, because WebAssembly is so new, there hasn't been a whole lot of attention paid to making that a reality. So from my perspective, Lumen is a project that in part is kind of trying to move that vision of the future forward.
I want to talk about this because I think I heard you guys on another podcast. I think Brian was talking about this, but you guys are actually, at least two of you, or at least for sure you've already made it quite clear that you're on the working group, but I think there's another person too. It's also
Al is also
and you guys
on
are actually
there,
helping. Oh, Al, okay. Yeah, you guys are actually steering stuff. So it's kind of funny that like this project Lumen that, no offense, is not well known.
Yeah.
But you guys are actually making decisions and helping to form a WASM that's going to affect basically everybody else in the ecosystem. And I remember, I think Brian was on the podcast and he was like saying like, hey, like there's a lot of other people who are doing the same stuff as us. I think, I forgot which languages, but he said but they're not participating in the working group, which is kind of not so smart because there's things that they need, which if they're not part of the working group and like push that they need it and state why they need it, that's never going to happen. Like maybe somebody says, well, we need this feature. And then the guys will say, well, who uses it? Nobody puts a hand up. Right. And so they say, well, skip it. Skip it for right now because it's not being used, although it's being required by these places.
You're absolutely right. And I think, particularly when that interview aired, we really did feel like we were the only ones that really cared about it in a real way, or at least represented kind of like the real world, if you will, versus academia. I don't mean to say that the academics aren't contributing here because they're largely the ones pushing a lot of this stuff forward. But at the same time, like I think we get dismissed if we're not on one of the browser engine teams. That has changed though. I've seen more participation from some of the other languages I know that are targeting WebAssembly. At least one of the meetings, at least one of the people from the Asterius team, which is basically Haskell for WASM, was there and advocating for some things. And we've gotten a lot more support from kind of some of the academics that are on the WebAssembly team and pushing some things forward that are interested in supporting things that are important to us. So overall, my sentiment has kind of shifted to it being more positive than it was. I still would say that, for all the browser engine teams, they largely are focused on playing nice with JavaScript, supporting JavaScript, and everything else is largely irrelevant. But I am seeing more interest from some members of those teams in enabling some new functionality. And I think it's because they've kind of reached a point of stability where they're more interested now in how can we kind of expand this out, enable some more powerful features so that more languages can participate, and be able to target WebAssembly. So I think that's, some of them have that vision, right? It largely depends on what your interests are. If your interest is in just what you need to implement the browser engine and support for new JavaScript features, then that's going to be what you care about, and that's going to be what you advocate for. And you're not going to be interested in supporting anything that kind of makes your job harder or isn't something that affects you in a real way. And there are still, I think, many of those people on those teams. Yeah, it's getting better. I feel much more positive about it, and I'm interested to see where we end up with things this year. I'm pretty sure we're going to be able to get something landed, at least kind of a stage 1 or stage 2 kind of proposal, assuming we can get agreement. The hardest thing at this stage is integrating some of these features with some of the other initiatives that are going on and interacting with JavaScript. JavaScript imposes some constraints on some of this stuff that I don't think we would necessarily be concerned about otherwise. And that's just because, JavaScript comes first on the browser engine side.
I'm kind of curious about how did you guys get onto the working group? Because, your background is Elixir, and you were still working at, Dockyard at the time, which is kind of known as the consultancy for Elixir, in my opinion. So how did you guys get onto the working group anyways?
To be clear, like the WebAssembly working group works a little bit differently, I think, than many other working groups that are like W3C maintained. The actual working group has like only a couple people on it. The community group is where everything really happens. That's different from other groups underneath the W3C umbrella, where the working group is kind of where the stuff happens, and the community group is more just interested parties. But WebAssembly, the community group, is where pretty much everything happens. That only requires that you sign up and say, I want to participate, and then you show up to the meetings and, make your voice heard if you want it to be heard. And then underneath that community group is various subgroups that are kind of driving forward the different initiatives that fall under the WebAssembly umbrella. And those just, again, require that you say, like, I want to participate in this group, send me the calendar invite and everything, and then show up to the meetings if you are interested in it. So it's much more informal than the working group processes that normally would be followed, where I think the way that typically works is you either need to be part of a company that has some sort of special classification, or you pay like some membership fee or something like that. Honestly, I can't remember how that stuff works because it is not important to me. But yeah, basically both me and Elle got involved immediately by just, requesting to be part of the community group.
So what's the relationship between the two? So it's just that like you guys are kind of more practical people that kind of come in and say, hey, this is what we need. And then that kind of bubbles up to the actual working group. And then they kind of say, okay, based on the community group and what's going on, we probably need to formally spec this stuff out. And then they kind of do like the last part.
Actually, all that happens in the community group currently. So that's why it's different than how it normally works. How it normally would work is what you're describing, where the community kind of comes up with various proposals that get handed off to the working group if they decide to uptake them. And then all the spec development and everything would happen in the working group. In WebAssembly, all that happens in the community group. So subgroups iterate on like a idea for a proposal. And then once they have something ready, that proposal gets brought up to the community group kind of globally, I guess, the main community group. And a vote is taken on whether that proposal should be made stage one, basically to move it forward. And if not, then it either goes back for more iteration or it gets discarded. Once something has made it to the point where it's stage one, then it's really up to the various stakeholders of that proposal to drive it forward. Ultimately, where it has to get is at least 2 implementations of WebAssembly. And in practice, this means browser engines have to have implemented support for that proposal. And once it's reached that point, it's essentially stage 4, right? Like it's ready to be kind of a mainline approved part of the WebAssembly spec. Why that is a little bit murky, I guess, is because there's the notion of the MVP. That's the original WebAssembly spec. And then a lot of these additional proposals that make their way all the way to like stage 4, they're like supported features or extensions of WebAssembly, but they're not part of the MVP. So they're like optional features. All these additional things get added. I don't know what the kind of future holds in terms of, is there going to be like a V2 of the WebAssembly spec that includes all these things? Are they always going to be optional? My expectation is that most implementations will have support for most of these finalized features with maybe a few exceptions. SIMD is an example where maybe a particular implementation can't support that because there's no hardware support for it.
Okay. Yeah, that's pretty cool. So you're saying it goes backwards then. So you guys come up with, maybe I misunderstood. So they come up with ideas and you guys kind of say yes or no. And then finally it's up to the browsers to actually do the implementation. And once you get 2 browsers to basically do this, which you didn't say directly, but basically that's usually what happens, then it's kind of part of the spec and then everybody else has to kind of catch up, right?
Yeah, exactly. And now that we have some like bigger WebAssembly runtimes that are not browsers, like WASMer and WASM Time, for example, like those qualify as an implementation, right? So they could take the place of a browser. However, like I think it's very unlikely that a proposal would be fully accepted if it implemented something in 2 non-browser WebAssembly implementations that the browsers didn't want to support. I'm interested in how that would play out in practice. I haven't actually seen that happen, but if that did, I would be interested to see, if it actually got accepted or not. I think in practice, if it's something that kind of goes outside the bounds of what the browsers are willing to support, it's probably not going to progress. But I don't know that we've seen that happen yet. So it's hard to say. It's very much browser centric at this point. I'll say that much.
Okay. That's good to know. Okay. I mean, I would love to kind of keep going on and on, but I think that we have to have an end to this at some point.
Yeah, sorry. I have a tendency to ramble.
I did see that you're also using Rust in your new job, right? And I think that we can, depending upon what you want to say and what you can say, we can talk about that maybe another episode in the future.
Sure, yeah.
And maybe we can go even deeper on what's going on with WebAssembly, because I think that topic could be really interesting. Like you said, WASI is something that maybe people want to start targeting because it's like, I have to compile for Mac, compile for Windows, compile for Linux. Well, why not just compile for WASI and I could just run that thing anywhere? That's an interesting topic to talk about. I don't know if you can give enough information about that, but That would be a lot of fun for people to talk about. So again, I appreciate your time.
Thanks for having me.
It's the day before Christmas Eve for you, but it's Christmas Eve for me over here.
Yeah.
So I appreciate you making the time.
Great holiday. Sorry for taking up your Christmas Eve.
No, don't worry about it. It's still morning time over here, so it's okay. I appreciate you kind of letting us do. But actually, there is one last thing. So you guys you took a break from working on Lumen, but there's some talk about bringing it back up. Is there any kind of call outs you want to do about people kind of come take a look or come participate?
Yeah, I mean, I think in kind of the timing of things we're looking at is that, I just recently switched jobs. That's given me back some time that I did not have. And I'm hoping to kind of push forward on some of the last pieces of the compiler that were holding us back or really preventing us from being able to say, like, here's a first version that everyone can kind of use and go to town with. We're hoping to get something shipped kind of in the first quarter here. Brian is looking at bringing on some additional engineering effort to help push that forward, basically taking care of things that I don't have time to work on. And so my hope is that that's going to help us kind of get that first release out the door sooner rather than later here. I think from the community's perspective, it probably makes the most sense to keep your eyes peeled for when that happens. And start, thinking ahead, I guess, or even working on like, what would you want like a UI library or front end library to look like, in Elixir, in Erlang, right? How would you want to write DOM driven applications in Elixir? I think that's something, we have some ideas around, but I'm very interested to see what the community comes up with there, because there's a myriad of possibilities, I think. How are you going to map? Are you going to have like a process for every DOM element? Or is it going to be like a process per component? There's different kinds of approaches there. How is supervision going to interact with things like that? There are a lot of kind of interesting things that fall out of having kind of that Erlang functionality in the front end. But yeah, I would think that until we have that first release out the door for people to actually experiment with and try writing applications on the front end, it's too early to get community involvement there. We do need some help with implementing some of the standard library functionality. So there's a lot of functions that we have not been able to implement yet, just because there's an enormous number of built-in functions in the standard library. We've got a lot of them implemented, but there's still a lot that remain. We're always interested in having people, help out there. And if there are people in the community that are interested in working on the compiler, like, we're definitely open to having more people participate there. There's a broad surface area of things to work on, and a lot of things that we would like to improve, but just don't have time to. So if it's a project that holds some interest for you and some component of it, I'm sure there's a way for you to contribute.
I think the best kind of way that I would want to look at it, the only thing that comes to mind is like writing my code as live view, where I would have a separate template and all this kind of stuff. That I think is pretty straightforward. If you can have it use basically live view, then you can easily port your stuff you can take your existing live views and then just compile those directly for WASM, which could be really interesting for a UI.
That would be, for sure. I know Brian has had some interesting thoughts that I haven't gotten into it too much with him, but he's been eyeballing how live view might work with Lumen, with things running in the front end. That'd be very interesting for sure.
All right. Again, thank you for your time. I appreciate it. And like I said, hope to have you back again. So we'll see you then.
Sounds good.